Hi everyone. In this video I would like to talk about how to describe positions of a point in the coordinate plane if the point is moving on a straight line. Right? So in this example I show the point C on the map, which represents a cyclone, and it's moving from point A to point B in one day. Okay, and so I can drag the slider to see how the point change. Now I will use the slider to describe the position of a point C with respect to point A and B. And D may also represent the number of days, okay, in this scenario. That means D, when D is 0, it is at the position A. After one day, okay, it will move to the position B. So when D is 1, it will now at B. In between, you can also describe any position of the point C by the parameter D here. Okay? So I'm going to show you how to do so. In the blank page here, I start with importing an image. Okay? So I've already prepared an image of the map. Okay, so I now open it and now import it. And you can see that when you import it, they will generate 2 points, A and B, for you to position. Right? The graph, you can even incline this. Okay, but I would like to put it in the standard position. Okay. All right, and so you can also click on the graph and then change the transparency. Okay, that will make it better, right, to be used in the graph. At the same time, you can also see that I can now position the center around the origin. Okay, and once you have done this, now I turn to change the label of the point, call it P1 and P2. Okay, and you can select the point P and turn it into fixed objects, okay, and then also include it as an auxiliary object. So it will not be shown on the algebra window now. And similarly, for the point 2, you can also make it a fixed object and auxiliary objects. Okay. Now in this way, then you won't be able to move accidentally the graph. Okay. But for the point P1 and P2, you can also hide it. Simply hide this, as you don't know. I think we don't need it now. Okay, now let's go back to the graph. All right, now I can scroll in a little bit. Right, zoom in a little bit here. All right, and now I start with 2 points. One is A and one is B. Okay, and assuming that A is the position of the cyclone at this moment, but after one day it will be here at the point B. So in between, how would I describe the coordinate of the cyclone? Okay. And then I need the parameter, so I set D equals to 1, but you can change it. Once you enter it, then you can change the scale. Maybe D can be simply a number from -1 to 2, and the step is 0.05. Okay, so a D will be a number changing from -1 to 2. At the beginning, at the point A, I assume that D is equal to 0, and after one day, okay, then D becomes 1. Right, and this should describe the position of the point C at B. Okay, and in between it can be a fraction. That means, for example, if D is 0.25, that means it is the position of the point C after a quarter of day. Okay, now we go to describe the position of C. We can do it in several ways. Let's set it as call it H. Right? We call the x coordinate of C a value H, and this one can be consider as D, a fraction, right, times the x coordinates of the B minus x coordinates of A. Okay, so I would just type x brackets B here, representing x coordinate of B minus x coordinate of A. Or you can read it as the one inside the brackets means the difference between the coordinates of B and A. When I say different, it is B minus A. Okay. And so you assume that you are starting from A going to B, and then you think about the change. It doesn't matter whether A is on the left or right of B, okay, as this expression should represent the change from A to B, and even it can be negative. Now this change I multiply by D, because may not be one day, okay, it can be changed in half or quarter of the day, so you multiply this by D. And this amount is added to the original position A. That means the coordinates of A here. All right. So the whole expression means that from A here, from the x coordinate of A, you add a quantity which is a proportion of the difference from B to A. Okay. So that will give you the x coordinates of the point C you want. Okay. Now similarly, I can also do the same for the y coordinates. And now I'm doing something about the y coordinate. Okay, so when I finish, I have two values, h and k, representing x coordinates and y coordinates of the point C. Now I can define C to be the value, the point with the coordinate hk. Okay, h and k here, so I will give the point C. So let's have a check. If I change the value of D, then you will see the position of C will be changed. Okay? And you can change this color to make it easier to be recognized. Okay? And you can try it again. So let's look at it. When D is 0, C is just at the point A. And when D goes to 1, okay, here D is equal to 1, then C is at the point B. And something in between, for example 0.5, it will be midway between A and B. And you can also see how the calculation will give you these values. Or you can also adjust a little bit. Okay, let's say we go to 0.8 or 0.75. Now that means we now cover 3/4 of the distance from A to B. Right? And this will be reflected in the expressions here. Right? Now it doesn't matter what is the original position of A and B in this graph, so I can now arbitrarily change the position of A and B. Right? For example, that means I start from A and then go to B, and then somewhere between, somewhere on this way, covering about 3/4 of the distance or the journey, then the point C will be here, given in the same way by the expressions that have been entered here. Okay? So you can change it again. Okay. And so I now go back to the original position, for example, something like that. Well, not the original one, but it's easier to compare now. Now you can also notice that D can be a value greater than 1. That means when you move slowly from 0 to 1, now it will be at B. But after 1 day, you can also continue to change the value of D, okay, and see where it is. So it is here now at the value D equal to 2. That means 2 days. Okay, at the time of 2 days, then C will be here. Right, so it is also given by the same formula. Similarly, if you drag it back, okay, then you can also talk about negative values of D. That means before it arrives A, let's say, if I move it to -1, then you can see that 1 day before it reached the position A, C should be here. It is also expressed by the same formula, actually. Right? So you can move around to test it, and even change the positions of A and B, right, to experience the results of the calculation. Now I can also talk about further about these expressions. By the way, all these expressions on the algebra window, you can change the way to display the result. That means how you can see definition value. You can just see the value, concentrate on the values of different things, or concentrate only on the definition. Okay, this will give you the same different ways of looking at the objects here in the algebra wheel. Now let's return to the expressions of h and k. I can rewrite it. Some will prefer actually writing it in another way, even though this may be the one I prefer. Right? But by the way, textbooks sometimes will express the expression in this way. It can be d times x of b, okay, and then plus something times x of a. You can group the two parts together. Right? Now I can rewrite this as d times the coordinate of b plus, and if you try to remove the bracket and rearrange the term, then what's behind will be 1 minus d times the x of a. Okay, you can rewrite this expression and check that whether they are equivalent. Now I can rename h to be this expression instead, so it will be the same thing. Okay, so I can rewrite k again in the same way, d times the x, is y of b. Sorry, I don't need the bracket here. Okay, the y coordinate of b, and then plus 1 minus d times the y coordinate of A. Okay, so I can rename it as K. So replace the original expressions. So now C will be represented by these two values. Now if you check the slider, then you will see the effect is the same. Okay. So it just let you know that the expressions can be rewritten in different ways. Okay. And by the way, in the Hong Kong curriculum, we may call this the point of divisions, right? Between 2 points or on the line segment, okay, and given by given ratios, right? And here the ratio is d to 1 minus d, okay? But generally it can also be expressed in this way, particularly if you go on further to learn about vectors. You'll find that this is the same as talking about how to express the vector OC from OA and OB. Okay, actually I can also type in the same way, so I can now cancel the point C. Simply type C equals D times the point B plus 1 minus D times the point A. Right? Or you can say that this is the vector B and the vector A, and then it will give you the vector C or vector OC. Okay, and just press enter. Right? Then you will see that now it will be more or less like the vector form actually. Okay, you're working on the coordinates directly instead of using the two values h and k. So that means I can simply delete h and k. Right? Then you will see that this point C is basically describing the same point, right? So that is even more concise way to represent the coordinates of a point in the graph, right? And so I can change the color again and turn it into a cross and change the color and even start to trace. Okay, so I can turn it into a trace. Turn on the trace, and then I can now drag it slowly. Right, then you see the whole path, right, of the point C on the map. Right, so this is the end of the demonstrations today.